Okay, cool. So I guess we are back. Okay. And today what we will look into is something known as binary lifting. Okay. And it would be a kind of continuation of trees only. But yeah. Now, as usual, did anyone hear of this term binary lifting? I mean, did you know anything about this, what it does and all? Okay.
No, bro, no idea.
No idea.
No idea, bro.
Okay, fine, cool. So let's take a kind of inspiration problem and let's see, okay, what can we do? Uh, Say you have some data structure, okay, say you have some data structure, maybe linked list, okay, maybe a random linked list. So how the linked list look like? Is it something like this? Something like this, right? That you always have a pointer to the next node itself, right? Now, let's say
Yes.
I'm standing here. I will tell you, bro, can you tell me what is the kth node from here? K, let's say k equals to 3. Then from here, first, second, third, right? Let's say if I ask you, bro, can you from here, can you tell me what's the fifth node? So in that case, the fifth node is this, correct? Which is
Yes.
nothing
Yes.
but going one step at a time till k, right? The problem with this is, okay, so probably now we are at the stage to understand what's the problem, right? The problem is what we are doing is we are going step by step, correct?
Mm.
Imagine I give you q queries. For q queries, I will give you a starting position and I will give you k. And I will ask you
Mhm.
from that starting position, you have to go to k nodes and you have to print that node as something. Okay. How will you do
Mm.
that? Okay, obviously we are
Yeah,
talking about,
brute force.
yeah. So brute force would be like go one step, I mean each step one at a time, and till k is greater than 0, go, and
Correct.
somewhere where we will reach, that would be our answer. So do all of you agree with that, or do you have any better approach than this?
Yeah,
No.
that's all, bro.
That's all right. But it turns out to be that there is one more better technique. Okay. Okay. So let's talk about what's the time complexity of brute force. The time complexity is O of k, right? And since we will have q queries, it will be nothing but O of qk. Agree?
Correct. Yes. Yes.
Now, there is this binary lifting technique, okay? Or we can do it, I mean, before binary lifting also. Can you try to improvise this? I mean, can we do some stuff on this? I mean, can we apply some technique and maybe solve a problem? So what if I build a table, let's say any table a of I comma j, that if I am at the ith node and if I give a distance of j, can we calculate that? Let's say like I am standing at this node. In the initial, I mean, before starting any queries, I can build one array, right? 2D array. And for that 2D array, I can store that for every node, what is the other nodes? Like, let's say this is node 1. For node 1, uh, at a distance of 1, there is this node 2. At a distance of 2, there is this node 3. Can I build for all the nodes in the starting itself before processing any query?
Yes.
And
Yeah.
in that case, if someone asks me that, bro, can you tell me from second node what is the third node? I can easily tell it's 5, right? Because I will store that before computing, I mean before solving any queries. True.
Yeah.
Yeah.
Okay. So in that case, the time complexity will be, the first thing what we were doing is we are building an n square table, right? N square
Correct.
table, and I mean, which will take a time of obviously n square. So we are doing an n square work before processing any query, and as soon as we start solving the queries, it would just take me order one, right? Constant time, because we can get it easily from our array. So 0
Yes.
into 1. So overall, it's like n square plus q. True.
Mm.
And the space will also be n square. But again,
Yeah.
what if n is up to 10 power 5? Okay, from the first case, we have obviously improved. Now, instead of going through k times, we are just checking a constant. But there is this large factor n square, which will tell that, okay, you have to compute everything in order to solve any query, right? So this is the factor which is actually taking a lot of time. So till the point where we have come, what we generally see is whatever the factor which is causing an impact, let's try to kind of reduce or boil it down, right? So if we can somehow reduce this n square to n log n, what do you think? Will it pass in that case if n is up to 10 power
Yes.
5 also, right?
Yes.
And if, let's say, each query, if I tell you again in log n time, then also it will pass, right? Let's say the building will take n log n, and for each query I will take log n. So if I have 10 power 5 queries also, it will obviously pass in time, right? Because we know how fast log is, right?
Yeah.
So
Yeah.
let's see how we can solve this initial problem. Okay, I mean, we will see how it is being solved. Okay, so let's take the same example only. So say now I am standing at node 2 and my k equals to 5. Okay, or maybe let's write a little bigger example, maybe, because that would have a more good visualization. Okay, so let me draw little quick. So is this lagging, guys? I mean, I can see
No,
that.
nothing.
So at any instant, if you guys are not understanding, please let me know. Okay, because this is a totally new topic, right, for you. So okay, now I am here.
Yeah. Okay.
I am here. Let's say I want to reach k equals to uh mm, okay, tell any number. Okay, let's, you guys tell me any number will be.
3.
Okay, let's increase it. Probably 7, Sam. Will it be okay?
Okay.
Okay. So
Yeah.
in my case, the answer will be 1, 2, 3, 4. Can I say this will be the answer? This note. 7 steps. 1,
Yeah.
2, 3, 4, 5, 6, 7. Okay. Now, can you see k equals to 7? Every number can be written as a binary number, right? Which is nothing but 2 square plus 2 power 1 plus 2 power 0. If I can, from this position, instead of, I don't know where is my 7th node, but let's say if I somehow know what is my 4th position, the 4th position is this. From here, if I go more 2 position, and then from here if I go to first 1 position, can I say this node will be my final answer, whatever was required earlier,
Hmm.
right? Obviously it would be a bit confusing at the start, but are we reaching to the same place where we want to,
Yes.
right? So
Yeah.
what I am
Yeah. Yes, bro.
what I am saying is every number can be written as a form of binary numbers, right? So let's
Mm.
say
Mm.
guys k equals to maybe 11. Okay, so 11 can be written as 8. Can I say this is the one?
1 1.
Okay, so
Yes.
let's say from here maybe I can go, this is nothing but 2 cube, right? This is 2 square,
8.
this is 2
Mm.
power 1, this is 2 power 0. Wherever we have set bits, okay, in the case, let's say if I'm starting from here, what I will do is I will go to 8 steps ahead. Okay, let's say some 8 steps, then 2 steps, then 1 step. And will the answer be same? The 11th node,
Yes.
right? So the idea of binary lifting is rather than jumping one by one, jump in powers of 2. Okay, this is the power, this is the idea which binary lifting gives us. Okay, that instead of jumping sequentially or one step at a time, jump in powers of 2. Okay, with that our problem can be easily solved. Okay, now see, k equals to, so any number will have how many set bits? If n is a number, how many set bits will be there?
For n square, you're like 2 to the power, you're telling.
Given a number n,
Yeah.
how many set
Mm.
bits will be there in that at max?
31.
31.
No, obviously it's 31, correct, but how will you tell in terms of n only? Can I say it's log n? We learned this, right?
Yeah, yes.
Yeah, in bit manipulation, that given a number n, there will only be log n set bits, right? So now, since any number can be decomposed in log n set bits, can I say I can reach to my kth position in log k time, because there will be only be log k set bits. Does that make sense? No? See,
Yeah, got it.
given a number k, how many set bits will be there? Log k, right? At max.
Yeah.
So
Yes.
what we did here also in this example, we only went through the set bits, correct?
Hmm.
So can I say from any position, I have to only travel at max log k time. That's it. So instead of doing a create k number of traversal,
Yes,
we are
yes.
only doing log
Yeah,
k.
understood, bro.
Yeah, got it.
Yeah. So Deva, did you understand this?
Yeah, yeah, got it, bro.
Got it right? Okay.
Yeah,
Now the question is, how about, obviously we said that we can directly go from here to fourth position, right? But
Hmm.
we need to maintain this also, no? Like how can we go directly? If we don't
Yeah.
maintain, so how can we go? So for that we will create a table. Let's say the table name is dp of I comma j. Okay, dp of I comma j will tell me node at distance, node at distance 2 power j from I. Now does it make sense? dp of ij will tell me that
Hmm.
node at distance 2 power j from I. We will only store powers of 2 now. Okay, let's forget about all the other
Hmm.
numbers. We will only store only powers of 2. Okay, so let's say if I tell
Okay.
you dp of I comma 0, what will be the answer? Can I say it will be immediate next neighbor, I mean the next node? Think and tell me. This is I. What is 2 power 0?
1.
So 1 means this only, right?
Yeah.
dp of I comma 1 will be nothing but this.
Yes.
dp of I comma 2 will be nothing but this. Correct? Because fourth
Yeah,
neighbor.
yeah, yeah. 4, 4. Yeah, got it.
And this will be dp of I comma 3.
Hmm.
So if we can maintain this table, then it's really easy for us, right? To do the
Yes,
traversal.
yes. Yeah.
Now let's come into the important part. That is, how can we build this table? Okay, how
Hmm.
can we build this table? Now let's take a very simple example. Okay, Sam, are you following?
his internet got broken, so he will join, I guess.
Okay, so let's say guys, we are at node I. This is node number
Hmm.
1, node number 2, node number 3, node number 4, node number 5. Can you tell me dp of I comma 1?
It's 1, 2, 3, right?
Yeah, so what should be the value? 3, right?
Hmm.
Because 2 power 2 power 1 is this one. This.
Yes. Yes. Yes.
Now, dp of I comma 2. Deva, tell me this value. dp of I comma 2. What will be this?
5,
Correct.
5.
5, right? Now, can I say
Yeah.
this is nothing but 4, right? I mean, 2 means 2 square, which is 4. Instead
Correct.
of going here, can I say I can go here first and then go here?
Hmm.
So,
Okay. Again breaking.
exactly. So, I am writing something. Let me know if you are understanding this or not. dp of I comma j is nothing but dp of, in order to go to jth step, first I will go to j minus 1. Okay, first I will go to j minus 1. So
Mm.
dp of I comma j minus 1. So guys, if I have to reach from here to here, from I to j, I went I to j minus 1. So j minus 1 will give me this position, right? Do you guys agree?
Yes.
Okay. From here,
Yeah.
how many steps I should take now? Again, j minus 1 steps,
J.
not j. This is
Mm.
j minus 1. See, 2 power 2 square can be written as 2 power 1 plus 2 power 1. Do you guys agree with this?
Yeah.
2 power x can be written as 2 power x minus 1 plus 2 power x minus 1. This is true every time. So, in order to reach from this node to this node, first we will go to, instead of going from I to j, in order to know what will be the value from I to j, let's go from I to j minus 1 first, and from here also let's go to j minus 1. So if I write, can I say this is the value of dpij? Confused?
Yeah.
Okay.
Bro, isn't it
Mhm.
2 power x minus 1 into 2 power x minus 1?
This one.
Yeah.
So 2 power x minus 1.
Into 2 power x minus
Oh, is it? Okay, let me check. 2 power 2 into 2 power x minus 1. No, it is correct only, right? Sas? 2 power x equals to 2 power x minus 1 plus x minus 1. It is nothing but 2 into 2 power x minus 1, right? It is nothing but 2 of,
1. Yeah. 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 Oh, yeah. Yeah. Got it. Got it. Understood, bro.
yeah. So now from here to 4 positions
Hmm.
is not, from here to here is nothing but going from here to here and from here to here. Can I say that? Because 2 square is nothing
Yes.
but 2
Yes.
power 1 plus 2 power 1. So if you see the dp recurrence, the recurrence is go to dp I comma j minus 1, which will help me to go here. Now from here, where you need to go? You need to go one more j minus 1 steps. So dp of, I mean, this bracket comma j minus 1. Does this recurrence make sense to everyone? Deva,
Yeah.
Sam.
Yeah.
So it's, I am assuming that you guys understood it entirely, okay? Because without this we cannot go forward. So a quick yes if everyone understood. Otherwise, let me know here itself.
Like reason why j minus 1 going to j minus
So you said yeah just now.
1. Got like you told going like from here to here. Reason I did not get.
Okay, no problem. Okay, Sam. Let's say I'm here, Sam. Okay, this is
Yeah.
I. What will be my I comma 3, dp of I comma 3? Can I say this only? dp of I3 is nothing but 8 steps, right?
Yes, 2 to the power of 3. Yes.
8 steps.
Hmm.
So can I say I can go from, instead of going from I to j, let's go to I to j minus 1. So if I go to j
Hmm.
minus 1, can I say this is nothing but this?
Yes.
From here also, if I go to j minus 1, can I say my answer is done?
Hmm. Yeah.
So if you see the recurrence, first we went to this part.
Hmm. Yeah.
Now this will give me this node, this node.
Yeah.
From here I will go to another j minus 1.
Yes.
So now are we perfectly aligned with this equation now?
Yes. Yes. Like why j minus 1? I did not get. Like why we can't directly go to area dp of j?
dp of we are building this, right, Sam? I mean, dp is what?
Step
dp is
by step by step, we are coming, right?
building the
Hmm.
solution from the previous solutions. So
Okay. Okay.
how can you directly calculate j without some previous values? So this is the
Okay.
human
Okay.
nature, no? Ki
Y-
some value
Yeah.
will
Yeah.
be computed using the previous values.
Yeah. Okay.
Yeah. Okay. So I hope now we are okay with this.
Yeah. Clear.
Yeah,
Clear.
understood, bro.
Okay. So once done, okay, once done, now we have built our DP table, right?
Hmm.
Our DP table is ready. So if our DP table is ready, guys, now let's say I am giving you here. I mean, let's say I'm standing here and I say k equals to 6. 6 can be written as 1, 1, 0. Agree?
Yeah.
6 can be written as 1, 1, 0. So what is this bit? 2 power.
2.
So from here, till where should I go?
2 power of 1.
2 square only, no? This is 2 square only, right, sir? This is 2 power 1, this is 2 power 0.
Yes. Yes.
So whatever is there, just
Okay.
okay.
Okay. Okay.
So can I say dp of I comma 2 will give me this position? How many of you agree? Because we have built dp table. So dp of I comma 2 will take me here.
Hmm.
From here, how much should I take more?
One more.
So
Two. Sorry, two more.
2 more, right? 2 more is dp
Hmm.
of I comma 1.
Hmm.
And if you see, we have not traveled 6 times. We have traveled only 2 times, which is nothing but the number of set bits here. And
Hmm.
for the fact which we proved just now, for a given number, at max there can only be log k set bits. So we will travel only log k times. So this is how we are able to solve this problem using binary lifting. Okay. Now let's discuss little bit about what can be the space of this. Okay. So obviously we cannot create an n square table, right? Because if we
Hmm.
have created n square, then this is whatever we discussed somewhere here. This only would suffice. But okay, what do you guys think? Like, what can be the size of this table? Let's talk about first dimension. What about first dimension? What will be the space for first dimension?
N.
Exactly,
This one log n.
correct. So if n is up to 10 power 5 also, if you create a 20, because log of 10 power 5 is up to almost around 20.
Hmm.
So dp of n into 20, I mean dp of n log n is enough to create this, right?
Hmm.
And we can create this table in n log n time, and for each query we will be given k, right? And just now we proved that only we need to travel log k times. So the building time of the binary lifting table, which is taking us n log n, and for each query we are taking log k time, which will solve the problem. Clear? So is the theoretical
Yep.
part or the I mean, is it clear the pictorial wise
Yeah.
what we did in binary
Yeah.
lifting, what binary lifting is doing here, okay, and what's the power of this, right? Now, speaking honestly, it's actually a very powerful technique, okay? I mean, we don't know when it will appear, okay? So I haven't solved any question on lead code contest, but just to make sure that, okay, it might come any day, okay, and we have to be prepared for it, not to miss our rank.
Next week only we will be getting, bro.
Okay? So please be ready with, I mean, please see this technique, okay? I mean, not now, obviously, once we are done with the classes and all, because you understood what binary lifting is, so now it's all about exploring from your end. Cool?
Yeah, okay.
Okay, so this is the